In light of consumer demand to reduce greenhouse gas emissions resulting from power generation, nuclear energy is seen as a leading choice.
However, this technology doesn't come without issues. Some of the major downsides for nuclear energy include its safety issues, its complicated waste management, and its high cost. Nuclear pebble bed reactors have come into sight as a possible solution for resolving these issues. The technology was first developed in Germany in the 1970s.
Such reactors consist of spherical graphite pebbles filled with fuel materials such as uranium. This material is coated with pyrolytic carbon to prevent radioactive product from being released. An inert gas like helium is used to cool the reactor core and is then run through a turbine to generate electricity. Such technology increases the reactor's thermal efficiency by 40% compared to that of regular reactors. Also, this technology contributes to an inherently safer and more affordable plant as a reactor meltdown is impossible and no water management systems are required.
While the AVR did sell and supply power to the German grid, its purpose was focused on being a demonstrative technology, and given the novelty of this technology, R&D costs were considerably high and estimated to be $341 million. The direct construction costs of AVR were evaluated as $59 million back in 1984, and the relative impact of different costs is estimated to be the following.
Problems arose in the AVR pebble bed reactor due to its long operational time and high operating temperature, which was higher than other similar reactors. This led to several issues. The first is the accumulation of graphite dust produced by fuel pebbles upon contact. This led to issues during decommissioning due to dust being an additional source of contamination. Second is the difficulty in monitoring reactor temperature. This was due to the inability of pebble bed reactors to equip the core with instruments. This ultimately led to temperatures exceeding the design temperature by 300 degrees. These, along with the presence of radioactive fission products in the coolant, issues of oil and water leakage were the main issues faced by the AVR pebble bed reactor.
Clearly, this design of nuclear reactor faces its own unique problems, but the mistakes of the past serve to pave the way for the next generation of pebble bed reactors. Future versions such as China's HDR-PM and the USA's X-Energy plan to combat these problems by removing absorber balls and replacing the graphite spheres with low enrichment fuel spheres over 2 fuel cycles, and eventually high enrichment fuel spheres over 15 fuel cycles. This also serves to smooth the running-in phase from the initial core to the equilibrium core. Preliminary simulations of the proposed design indicate that it meets the performance and safety requirements of several key metrics, such as the maximum power per fuel sphere and maximum fuel temperature.
There are, of course, still hurdles to overcome, particularly associated with scale-up to meet commercial needs. However, pebble bed reactors are likely to form an important part of the energy supply in years to come.